Sir.
Yes, sir.
Yeah, so again, good evening to all of you. This is the first session of Math 2 and week 1 session.
Good evening, sir.
Good evening. So what we can do to like, I will just giving a good evening, Sneha. I will just give a brief intro of the course, and the process is to be asked in live session. If there are more doubts, then probably you will raise your hand, and then one by one I will go with that and will take your doubts. And second thing, the sessions would be like if it would be good, it would be good if we proceed with the like uh, go with whatever the like for each week there are 3 sessions allotted. So per week, like our session for each session is of 2 hours. Maybe it may go to the at least 2:30 or maybe 3. It's depend on how many doubts are there. So half of the time we will spend on clearing the concepts, and half of the time we'll spend on to clear your doubts, whatever you have activity practice, or if you have graded question to understand, you are facing difficulty to understand that, then we will discuss that also. And the process is, let me share my screen, then
Yes.
I will tell you the process to proceed the maths 2. Maths 2, let me say that. Okay, so I hope my screen is visible to all of you. Is that?
Yes, sir. Yes, sir.
Okay. So this is week 1. Okay. So in the first step, you can see about the course, and in this tab, you are able to see the links of live session announcement calendars to get the live session schedules, course playlist. There you can see each week, I think, all videos of each week, not only week 1. The tutorial each week, you can see the video. So if you want to go with the head thing, like to know more and more what is in week 2, week 1, then you can. And live session YouTube links you can get there. So this is just already you are familiar with the portal. No need to tell about it. Let me tell you the syllabus, just a brief syllabus. I hope all of you gone through the orientation session, or not all, most of you gone through the orientation. There we had discussed about the syllabus full of what is the syllabus in maths 2. I'm not audible, is that?
Yes, sir, you are audible.
You are audible, sir.
You are audible, sir.
Yes, sir.
Audible, sir.
Audible, sir.
Fine.
My voice is also loud, clear, is that?
Yes, sir. It's loud and
Yes,
clear.
sir. It is.
Yes, sir.
Yeah.
So in syllabus, like in week 1 and week 2, you will feel easy, because in these 2 weeks you will know about the system of linear equation, but it is very important topic to go ahead. You should to properly know how to solve a system of linear equation, at least when a system of linear equation has a solution, no solution, or infinitely solution. In week 1, I hope all of you at least watched once the lecture. There you can see this lecture 1.3 written about the system of linear equation. I will go one by one in the video itself. I will tell, and we will discuss those also, what is in video, taking along your questions of activity or practice. And I'm just giving a brief, then we will proceed with the session nicely. So I'm just giving the emphasis on where you need to be conscious about the which topic is at least necessary to understand the whole maths too. So like system of linear equation is very important to know the ahead courses, like when you come to in the vector space, at least when you come to in the vector space topic, having the topic one more topic is dimension basis word. There you will see the importance of system of linear equation. That's tell you then when a vector space has dimension, or when a system of when vectors are linearly independent or dependent. No need to worry, these terms you will familiar with slowly when you go ahead the course. And then after in week 3 you will see about the vector space. This is somewhat maybe many of you, not many of you, uh, at least someone half of the at least, or maybe half of 25% will maybe get the new, this may be new, the vector space thing. This is a not a total applied form, this is a pure mathematics, because vector space having a pure kind of thing. Let me mute to all of you. There is a
Sir, I have one doubt, sir.
okay, what's you have?
Yes, sir, actually, our orientation is also going on simultaneously. What
This
to
time.
do, sir?
This time.
Yes, sir. At 6 o'clock, we have got mail.
So
Yes,
I think general orientation session is, I think, not course wise. Course wise I have already done.
No, sir, it is course-wise only.
No. Course wise is already done. Here is the, you can see this orientation session.
No,
Maybe we
that
can
is
watch
old.
the recordings later on.
So it is on stream. It will be in stream on YouTube. You can see there also. And
Yeah.
course wise orientation session is already done. So here you can see that it's already
Sir, but
done.
that is old one, no, sir.
So this is the only, like, this is not, this is a term itself, the same thing is happening. So it's done already, because I'm saying the whatever things told in this video.
Mm-hmm. So we should join this or the orientation, sir.
No. So we be present. This is the first session. It will be good for you if you are very much familiar with the topic. Then you no need to be here. But if you are facing difficulty, having doubt in maths 2 this week 1, so you should to be asked. You can ask.
Okay, I'll be here.
So in this video, like why I'm saying the whole thing taught to discussed about the course. And last time, whatever the September term session is done, this is the same video have played, and we took the questions, doubt questions. That's all. So that's the thing. Okay. So.
Sir.
Sir,
for me now, I have CT also with Match 2. So my CT and Match 2 lectures are at the same time right now. So can you talk to the lecture or like the timetable committee and make sure that no lectures clash?
So all sessions of CT and Maths 2 are like matching this at the same time.
Not
happening.
all, sir, but like काफी सारे.
Maths 2 have 3 sessions, and I don't know CT have. Okay, yeah, I just noted it. Maybe I will discuss to the team having classing with the CT and Maths 2 sessions. Okay,
I have one doubt. Sir, I have one book with me, Linear Algebra and its Applications by Gilbert Strand. So for this Maths 2, can I refer that book and practice parallelly?
Yeah, it's good. It's good. Yeah.
Thank you, sir.
Yeah, it's good. If you are able to understand that, that's the good thing.
I have not started it yet. I don't know if I can understand. I will try. And
also you can see a book already mentioned in this the website already. Yeah, recommended in the syllabus itself.
Okay.
That you can see, or from my side, if you want to see, you can see a book, Fredberg, Linear Algebra by Fredberg.
It's mentioned in the recommendation, is it?
It's already mentioned there, Fredberg.
Okay.
No, I'm asking. I'm just asking. No, so it is not mentioned in the. From my side, I'm saying if you want to see that the Fredberg also you can follow.
Oh, sir,
Can you
Fredberg
repeat
is nice
name?
book, sir. Fredberg is very nice book, sir.
Fredberg is nice. It is a very in easy language. It's written already.
Of course,
It's
very
written.
easy to understand, sir. Exactly, sir.
Linear algebra by Fredberg. I don't know the whole name, but if you will search just a Fredberg, linear algebra by Fredberg,
So
you will
can you
get.
just put the spelling of that on the chat?
BERG Berg. That one?
Something is there. Where is it?
It is FRIED BERG.
FRI.
BD
FRIED.
BERG.
Fredberg.
Yes, sir.
Thank you.
So you can see that, or already mentioned in the syllabus. You can go with that. It's totally up to you. See, this is not a. If you are if you downloaded these three books like Gilbert, Gilbert, this Gilbert or this Gilbert, right? Fredberg or this whatever they mention in the syllabus. Like if you read that one by one, if you see which one is easy to understand, that you can prefer. It's totally up to you. So I was just discussing about the syllabus. So we in week 3 have this vector space thing, which is now the whole maths 2 ahead weeks are totally depend on the vector space thing. In then week 3, week 4 have dimension, vector space dimension, linearly independent, dependent thing. Then the terms new came linear transformation. This is full of based on this vector space. The vector space, why this is named vector space? Because this is an space. Space means as you are able to play on real line, right? So vector space the same thing. Are you will able to play on that set? If a set follows some specific property, then you are able to play as you are able to play in real line. Everything you are able to do as in real line, multiplication, addition, anything as you are able to do in real line. That's the term you can say. Real line also you can say a real space kind of thing. You can give the name as. So vector space is that the similar thing. So then after the words came linear transformation. Linear transformation is nothing but a linear transformation is nothing but a map. This is a mapping from a vector space to a vector space. So this is T here. This is nothing but a mapping, means a function with some specific property. It has some specific property, and the domain and codomains are vector space. This is you will study in I think week 6 and week 7. And ahead thing is when you studied, when you know a vector space, one thing added a term inner word, inner product in with this vector space, then this set or this vector space called inner product space. Okay, so this is you will see in week 8 I think, or week 9. So that's all for that's all to know in the linear algebra. This is all about for this maths to have this linear this term linear product. Then the new topic started there, multivariable calculus, that is called vector calculus also. So I hope all of you went through the maths 1 calculus portion. At least if you didn't go through, here it will just provided the questions and videos in the portal itself. If you not gone through that in the maths 1, otherwise you can go with all of you have, I hope, gone through the calculus portion. There there you will see the more broader application, or not application, broader form of this calculus portion. You will play with the not only one variable, with the more variable there. It is on week 9, 10 and 11. These 3 weeks have this vector calculus or multivariable calculus. So this is all about the syllabus. I just given the brief of it. Maybe you will feel easy in this multivariable if you are very much familiar with the calculus portion of maths 1. And the process is going to this course is the my suggestion is first at least watch video lecture. If you are not getting, you can repeat that, and please come to the live session. There, as I am saying, we half of the time we will spend on discussing on concept whatever taught in that week, and then we'll take the doubts, and we will try to be clear all of your whatever any like all of you have like how much possible to clear your doubts will be clear there will be cleared. So then like watching the video, so watching the video lecture, okay, once you watch the video lecture, so before going to this activity, just to go to this section, solve with assignment. This is very much helpful to understand the video lecture. There you can see the key points, whatever taught in that video lecture. Its written form is here, just keywords written of that video lecture. On and on that basis, the questions, very simple questions, just application of that, or application, or just a simple question on that whatever taught in video lecture. You can see that 1-2 question, whatever you maybe you will get. These questions are similar to or maybe exactly activity question, but not all. It is a different also. So watching after watching the lecture, yes.
Sir, but in which order do we need to, solve the activity questions after completing all the videos, or like week-wise? After completing 1.1, we need to solve activity question 1.1 and then move to watch the lecture of 1.2.
So one thing you can do, like if you are solving week 1, so what at least lecture 1 and lecture 2. Maybe it will be like that. So at least 2 lectures watch and then solve the week 1 week 1 lectures activity question, or week 1. So yeah, so as you are okay, as you are saying, so okay, so I will say first watch the whole lectures once. Okay, once watch the whole lectures. Like here in the week 1 have 5 lectures.
Your voice is interrupting again.
Sorry, let me mute too.
Yes, please.
Okay, so first watch the all lectures. Okay, then go to the solve with assignment. So like the first key points are depends on the first lecture. Second key maybe depends on the first or maybe second lecture, like that is there. So like once you watch, then solve these 2 questions. Maybe second key points also, if the from belongs from the week 1, then the second key points also. So like that you can go. Okay, so like the relation is, if you are not getting that this solve with question, go to the corresponding lecture, watch clearly, and then back to the solve with assignment. If you do like that, then you will get that okay, these things are like lectures, and based on the questions are here, lecture, and based on questions are here in solve with assignment. Once you did that, so these key points help you to understand the lectures also. Okay, so then go to the activity question. Activity questions are, there are 2 levels of activity questions. So the first level is easy one. The second level is you will get maybe tougher somewhat. The 5 questions are easy one, just it will not much difficult. Okay, the second level, if you are able to do the first level, is enough also. If you are want to feel some challenges, it is not also so much difficult. If you want to feel some challenges, then it's up to you. Go to the, not up to you, try to solve the level 2 also, to feel that to understand the whole topic also. Okay, there are 5 questions in level 2 also. So like that, in each activity you can see having such thing. And then after solving each activity, then go to the practice questions. Practice questions, practice assignment is very much similar to the graded one. Graded questions. These tutorials are also there. So yeah, one thing is that like watching the lectures, then go to the tutorials also. The tutorials contain solving the questions. Tutorials are you will see that there in that having concept also, some tutorials, and some tutorials tells you the geographic interpretation of the vectors or system of in linear equation. Okay, and so it will help you to understand the lectures also. Okay, so it's totally based on you that okay.
Sir, are the practice assignments, do they have a deadline? Because in this it is given that by today it has to be completed.
Yeah. So this time there is a deadline thing given to the practice assignment, because after this, then you will get the solution of it. So it is like that. Who wants to try yourself? It is given like that. Who wants to try yourself? Submit that. This is not this practice assignment is, I think, not given to for evaluation your this graded.
I guess it carries some bonus marks, sir.
Okay, it carries some bonus mark. Okay, yeah. Is that okay?
So, but in terms of bonus mark, which mark will be taken to be evaluation? I mean, before the deadlines. I mean, if I submit the this assignment before the deadline, will that marks?
I think in it is given in the handbook of maths too. So I'm not sure. Yeah, but the purpose is
Yes.
it's already written.
Grading pattern, sir.
Grading pattern. Okay. So yeah, you can see there what's the process.
Okay.
What's the bonus mark?
Hello, sir. Sir, I have a general question. Like if we have target for the S or A grade for this course for maths 2, what should be the strategy for us from like week 1 to week 11, 12?
So like, see, there are two quizzes, quiz 1 and quiz 2. So quiz 1 is or contains from week 1 to 4, and quiz 2 contains the syllabus from 4 to 8, like that, or maybe not 4 to 8, from 1 to 8. So then end sem is there.
Yes, sir. Understand. But want to know that how many times have we spent for S or A grade, something like that.
So if you are very much clear with the concept, I don't think it will difficult to get a good grade, because the quiz questions are not. It will not so tough. I think it will be very much similar to grader is somewhat. You will feel somewhat more difficult to the quiz one. Which one will be not like so much to it, maybe direct interpretation or so. Sorry, which questions are not so difficult. It is like that. If your concepts are clear, then you are able to do the questions of whiches. Okay. And the process, what I am saying to understand that what I just now said, go the lectures and tutorials, watch the lectures, watch the tutorials. Then go to the so I forgot to mention that watch the lecture, then watch the tutorials. Okay, tutorials having the solution. Tutorials contains the solution of questions also, or maybe concept also. So like when you see the question in tutorial, try to already watched the lecture, so try to solve yourself. If you are unable to solve, then see the whole video, then you will get at okay how to solve this particular question. So watch the lecture, watch the tutorial, then go to the solve with assignment. Okay, there you can solve the just infer of the lectures, can solve the activity, some simple question, then go to the activity question, solve there, and then go to the practice. Practice are very similar to graded one. If you are able to solve yourself the practice assignment, then graded will not feel much difficult. Just maybe different number, or maybe somewhat different. Not it will be not it is very similar to the graded one. Then you will not feel the graded is tough. Okay. Okay. So who is very much familiar with the topic? It's totally up to him that how he is treating. It's if it is already in maths background, already from the BSc mathematics, then he will just go to the practice assignment, or he just go to the graded assignment, solve or submit the assignment. That's all. It's totally up to which background the person is belong. Okay, this is all about to proceed this maths too, I will say. So let's go with now
Sir, so how many live sessions do we have for a week, sir?
Per week for mathematics, there are 3 live sessions for maths 2.
Okay.
And schedule is already given to this here.
Sir, is it fixed, sir? That means every week on the same day, sir.
Days are.
Is it like that, sir?
Day and timing will be probably fixed. Very rare case it will be changed. And you will get already the information.
Yes,
information you will see in the calendar itself. Okay.
Yes, sir. Yes, sir.
Schedule have changed. Okay. So what is the YouTube link? Okay. So practice have deadline because of this bonus mark, I think. So you can go with the handbook of the whole course. You can see there where is the bonus mark, where is there is not. Like so I forgot to mention that, like asking your doubt in this live session also. And there is one thing, this course is very much you will find here. For this course, you can see the questions are posted there. You can post your query there, and it will be answered there. Okay, like here, there are more like in here you can see that students are discussing there also how to solve. Like this is a particular questions like here. So instructor will be asked, not will give you an idea how to solve. They will not exactly give the solution, they will give idea how to solve. Maybe someone give the solution of the question, or maybe give an different idea how to approach that question. So discourse is very, very important. If you join that, you will get it will help you to understand or it will help to solve the activity questions, practice questions. And if you are not able to solve that, just ask here, adding this new topic, you can ask your question, okay, how to solve this activity. Then the student will answer itself, or the instructor will answer that your questions.
Sir, hello.
Live session are not updated in the calendar.
No, it's for week 2. It's now maybe tomorrow you will see that it will be updated for week 2. Week 1 is already it's there.
No, sir, for week 1 also it is not in my calendar.
Yeah, hi. Just 1 minute. Just 1 minute. Okay, you can see that here for me. It's already here. So yeah, just refresh the page. You will see that it's already scheduled. Like 6 p.m. is there. And
yeah, sir. It doesn't subscribe till now.
Okay.
For the calendar.
Okay. So somebody was asking something.
No, sir. I'm just saying like he doesn't subscribe the calendar till now.
Okay.
Yeah, that's right. Sir, I think we have to start off from matrices like.
So okay, so yeah, so please go to this discourse. Discourse is very much helpful to understand the concept.
Hello,
also. Yeah, hi.
Yeah. Sir, actually I'm from direct diploma. So
okay.
We guys from direct diploma were not able to access this discourse form.
Oh, is that?
Yeah.
Yes, sir.
Okay.
Sir, I think they need to send a mail to get access. I think they can get access to it if they send a mail to the support team.
So please write to the support mail saying
Okay.
to be we want access of this discourse.
Okay. Okay, sir.
But we have already got an invitation to join the discourse. Check your mail probably.
Okay. Okay.
Yeah. So is that, if it is such kind of, then please check your mails.
Oh.
Hello.
Yeah. Hi.
Hi, hello, sir. Sir,
Yeah.
the book just you mentioned, can you please show the picture of it because I'm not able to find it.
Okay. So
One student has shared the link, I guess, in the chat.
so in chat you can see, and also see, I forgot to mention one thing also. This time there is you see this book which written by instructors. Okay.
Yeah, yes.
So this will also very much helpful to understand the topic. This Maths 2 book. This is written from week 1 to week 4. When you come to till week 4, it will be added to the head weeks also. So this linear algebra written by these instructors, Subhajit, Susmita, and me, Subhasis, 4 instructors. There you can see that what is all about, what is vectors, matrices. It will help you to understand the topics also. This is system of linear equation. The questions are activity questions. There you can see, and the concepts have discussed there. Basis and dimension is contained week 4. Have inner product, linear transformation. So if you go through, if you go through that, it is like revising the concept also.
Okay. Sir, I found error in page number 31, sir.
Sorry.
I found error in page number 31 book. In this book.
This book is on portal.
Sir, I have a book, but in this book have error. Page number 31.
Okay, okay. So yeah, there is, so the discourse have given, see, this is just written and given to you. So if it contains error in the discourse, already it's given the feedback. Please feedback here, more Maths 2 book. Please feedback there, post there. So that's the thing, like it is given, see, it is written, if you are finding this, there is a small error. The errors will be the typo only, not conceptual. The errors will be the typos, maybe English errors, or maybe some terms are written typos, typo error. So
The
those
few answers are given wrong, sir.
answers are, so please mention that. Okay, if some activity contains the wrong answer, it will have, so please, so that's the thing. You can give the feedback here. This error is here, this error is here. Okay.
Okay, sir.
So it will be updated. It will one by one. It will be updated.
Sir, is there a book after 4 weeks?
Yeah. So yeah, it's after when you reach to the week 4. So you will get the book of free from 4 to week 8.
Okay, sir.
Sir, I have a general question.
Yeah, you can ask.
Yeah, sir. What is the difficulty level of Maths 2 and Statistics 2 combination in one term?
Okay, so Maths 2 have also contains a new an abstract notion like vector space, and Stat 2 also, I don't know, but yeah, if you are in the combination of Maths 2 and Stat 2, you have to spend more time on for this course. Enough time, maybe more than that, to understand or to clear this course also, to get a good grade also. So because Maths 2 and Stats 2 are, Maths 2 is totally content new. It is not, you will see in the, it is not from till 12 standard. It is a BSc course. BSc topics are here, contains BSc topics, linear algebra thing, and vector space, and also multivariable. So it is a new, maybe many of you get a new thing. So in comparison, I don't know which one is difficult, which one is easy, but both contains new topics.
Sir, I'm having a doubt in one question. Shall I post it here in the chat box?
Okay.
I wanted to ask something. We have vector algebra.
We also have vector geometry like vector and planes.
Sorry. Can you repeat again, please?
As you said, we have vector algebra for this maths 2 program. We also have vector geometry like we had in 12th standard, vector and planes and that stuff.
No.
We don't have
So,
vector geometry.
no. Just this is maybe you will see in the tutorials geometric visualization of the vectors, but that's all to that is given to understand the topic. What is the geometric visualization of the topic? Like
Okay, we don't
system of
actually
things.
have to solve for it.
But no need to be go with that, like to understand properly coordinate geometry, 3D, 3 dimensional coordinate geometry, solid geometry, that's called. Okay,
Yeah.
Akshaya, I will take your I will. Mahesh is also. So okay, so now I will not waste your time on these things. That's all from my side. I spent it 30 minutes.
Excuse me, sir.
Okay, yeah. Yes.
Can you help me? How can I post query on Discourse as I'm not used to do it?
So how to post a question in Discourse? Is that?
Yeah.
Okay, so I think it's opening like this. You can click on here, new topic. Okay. And if it is written like this, if it is helpful for you, you can or you can erase it.
Okay.
And you can then, so it's how it is. This is
Yeah.
written which topic having doubt or what is here. You can do. It's totally up to how you will do that.
Okay. And so one more general question. As a non-math student, most of topic goes over to mine. So even if I take home the actor, what can I do for such issue?
Sorry. Can you repeat again? Sorry. You
as a non-math student, most of topic goes over to mine to me, even if I take out the lecture. What can I do?
Maybe you will face this vector space and linear transformation. Okay, so let's go with the questions and doubts. So my thing is, before starting the topic, I will first take your doubts, activity doubts, and first clear that, and then we'll move on to discussing the concept first, because many of you have like just ask and leave this session. So I want to, like, if you want to just clear your doubts, you can ask and can leave the session. It's totally.
May I, sir?
Yeah. So just 1 minute. Let me go with, because I am looking there are 10 people have raised hand. So let me go with one by one. The first one is Shrutika Agrawal.
Yes, sir. So my doubt is in activity number 2, question number 6.
Okay, so activity number, activity AQ 1. Okay, 2.
And question 6.
त्याच्यानंतर आता काय करायचं माहिती
नाही. Please everyone mute yourself who is just asking.
त्याला विचार सेम टाकून देशील अरे एक
Let me mute all of you. Okay. Shrutika, you can unmute yourself to communicate. Okay.
So now is why is the second option not correct?
This one. If A is a square matrix of order 2 and A square is equal to 0, then A is equal to 0. So why you are sure that this option should correct?
Sir, I think it could be a possibility. I'm not saying that A will always be 0, but A could be 0.
A could be 0. So this option is given. See, A is not mentioned anything like A is 0 matrix or anything. It is just asking if this is happening, then A is exactly 0 or maybe different. So if each case it is A is 0, then this option should be correct. If it is not 0, then how it could be?
Yes, so it is not taking the possibilities. It is.
Yes.
Okay. And so when we use matrices, so we count rows as 0 row, 1 row, 2 row, or like first row, second row, third row.
Okay, so no. Can you repeat again, please? That If you are going to with the matrices,
Yes,
so
sir.
so this is in order. You can take this is going to be first row, second row, third row, and the columns are will be this is the first column if it is the first column is here. So this is first column, second, third, like that you can think.
Okay. So in general, it is not starting from 0 in mathematics.
Starting from 0 means
Yeah, sir. In CT, we have matrices, and while coding, we use as 0th row and 0th column.
no. So it will be like at least 1 cross 1. It's at least contain a non-zero or it will be a 0 kind of. This is a 1 cross 1 order matrix.
Yeah, sir. Like, sir, the doubt was that in CT, we just start counting from 0. That was the only issue there.
So because of that is a computational, like that system does this, that's why it is. But this is mathematics, so in mathematics there is no zero kind of thing.
Sir, in computer science we always start with 0, but since in this is mathematics we start from 1, if I'm not wrong.
Okay, so Sritika is done. Your doubt?
Yes.
Okay, Muskan.
Yes, sir.
Yeah, hi Muskan.
So my doubt is from activity 1.4. Question number 8 and 9.
Okay, so this is 8 and this is 9. Okay.
Yes, sir.
So what's your doubt here for this eighth question?
So in 8th question, I tried to solve the question by taking out the multiple 10 from second and third column.
Okay.
So like if there are two multiples of same number, then a property of determinant say that it will be 0.
Okay.
But the answer is not giving.
Are you
0.
using this? Are you using this hint? Hint is observe that a given matrix is of this form, A, B, C, and.
No, so I can't get this, sir.
Yes, sir. I had the doubt in the same question. This
I'm
hint,
not understanding this.
Yeah, me too. I couldn't understand what's the hint given there.
So hint is that like that if it is like this, if two rows are here, this is the first row, second row. So the determinant of this matrix is same as when you subtract with this row, second row. So if you do that for this matrix, like the whatever the hint is given, suppose this is what is that in hint? A, B, C, and this one is BC, CA, and AB, BC, CA, and AB. So if you do a row operation, subtracting the first row, or maybe like this, first row, this is then subtracting the first row from the third row. So what you will get here? 0, right? C minus A, and AB minus BC. You can get, right? And the first row from the second row. So this you will get 0. This is B minus A, and this is CA minus BC. And the first row is as it is, right? It will not affect the determinant. So see, this is BC, and if you take the common C here, sorry, BA, if you take the common C here, it will be A minus B, right?
Yeah.
So it is like the second row is C, A minus B. So now if you take common A minus B from the second row, take A minus B common. So what you will get in determinant? It will be in matrix A and BC. Here is also 0 time A minus B, right? You can think it here, 0 time A minus B. So it is 0, and it will become, this is A minus B is here, so you can change it minus time A minus B, right? So it will become -1 here, and this is C here. Similarly, you can take here whatever the common is here, you can match and take the common, and it will become a simple matrix. Now expand this matrix according to the first row, and that get easily answer. Like that you can think. That's the hint is given, like how you will take common. No need to do more calculation here.
Sir, may I speak?
Thank
Getting
you.
right?
Yes, sir.
Excuse me, sir.
Yeah. So if you have doubt this with the same question, you can ask. Yes.
Sir, what so what my approach was like I tried row transformation to create a upper triangular matrix and tried to solve it, but it became more complicated. Is it possible to do like that?
So how you are changing this matrix to in the triangular matrix, upper triangular or lower triangular?
Sir,
In
we
the
have
the
this
addition form.
row transformation, sir.
Okay, row transformation.
Yeah, I was trying to do it by row transformation.
Row transformation means as I did here, right? I also did row
Yeah, yeah.
transformation is first.
Yeah,
Yeah, that's
we got one in column one, right? So we could use it.
Yeah. So that's the process. That's why the hint is given to understand. No need to do the calculation. So you see, for this matrix, if you evaluate the whole determinant itself, if you give the number to this A is whatever this particular A is this 2010, B is 2020, C is 2030, then just substitute the multiply whatever the determinant you are getting for this A, B, C kinda. If you substitute that, you will get the answer also like that. The hint
Okay.
is given for this purpose. Okay. So remain to Muskan's ninth question.
Yes,
That
sir.
so what's doubt here, Muskan?
So if like in the question said, B is a B matrix is adding 2 times the first row of A to the third row of A. Means the first row of B is what we're getting by adding 2A1J plus A3J.
Okay. Okay.
It will be the first row of matrix A and adding 3 times the second row of A
to the
to the
first
first
row.
row.
So so if you are doing that, so what's happening? So it's
it will be 2 into 2 cross 3 matrix now, sir.
2 cross 3. Okay, but here is no. So if A is a square matrix of order 3 and
Yes,
B
sir.
matrix is obtained from A by adding. So what is happening here? What is so doing this question is the better way is you don't know matrix A. So write that A1, A12, A13. Okay.
Yeah.
A21, A22. If a matrix is not given, the best thing is assume that the matrix is like this. Okay, this is the matrix. Now matrix B is this is your matrix A. So matrix B is obtained. How it is obtained? As written here. What is written here? 2 times the first row of A to the third, adding to the 2 times. Okay, so let's add first row, adding 2 times the first row to the third row. Okay, so let's do that. So this is A11, A12, A13. Still remain to B. Let's do that first. And 2 times. So this is A31 plus 2 times A11. Okay, A32 plus 2 times A. Like multiply the with 2 and then add to the third row. So I am doing here, as you can see, this is 312 and A33 plus 2 times A13. I just multiplied 2 and added here. So this is now we obtained. Okay. And what is the next one? Adding 3 times the second row to A to the first row of A. So means what is happening here? So A21 is the same, A22, this row is same. What is happening here? It is added the 3 times of A21 to the first row. Right? So whatever you are getting, this will not see whatever the matrix you are getting here. If you calculate the determinant of it, you already know that if you are adding a row to the second row, it will not affect multiplying a row with a number. Okay, and then add to another row, the determinant of A is exactly will be the same, right? If you are
Yes, sir. Yes,
so
sir.
what's the mean that determinant of B is exactly the same determinant of A because as whatever the operation is given, because multiplying a particular row to the another row, so it will not affect the determinant of B. So whatever you matrix will obtain, but determinant of matrix B is exactly the determinant of matrix A. Now I hope you get the idea and you can do this one, right? This question added the thing.
Sir, it would be 2 times the determinant of A, right? Because we multiplied.
No. Why?
Oh, okay. I get it. Sorry.
So there is the property of this another matrix have determinant of a multiplied matrix is the same as determinant of matrix A into determinant of matrix B. This property is uses here, another property.
So, but in question, it is asking C A squared B inverse.
B inverse. So
Yes, sir.
another property is determinant of a matrix A inverse is exactly determinant of this one. This property is needed. And one more property is that determinant of K time O, K is an scalar, suppose the real number. I'm saying scalars are a real number. Okay, so K is a scalar or real number when multiplied with A. Means what is here? If you are multiplying K with this matrix, what will happen? K time each entry will be multiplied, right? This is the mean to K time A. Okay, this is the mean of multiplying K with a matrix to a matrix. Okay.
So could you repeat that last part again?
What I'm saying here, if you suppose you have a matrix, okay, and you are multiplying this matrix with a real number. So how you will multiply? You will multiply each entry with that real number. Like what will happen then? This is, if it is K time A, so it will be like this: K time A 1 K time A 1 2, K time A 1 3, K time A. Each entry will be multiplied with K. This is scalar multiplication with a matrix. I hope if you've gone through the video lecture.
Yes, sir. Sir, I have a question related to this thing. If I multiply a constant to a certain row or a column, then it would be that constant in then the determinant of a matrix would change to constant into the determinant of that matrix, right?
Yes.
So
I will discuss that concept. I'm this time is just taking your doubts. Otherwise, I will discuss the concept as well.
Yes, sir. I have a doubt about that. So just above you just took common something, right, in above matrix. Yeah. So you took common from a one particular row, but when you write it like that, and like just you currently showed, the k constant got multiplied to every element in the matrix, right?
So
yeah.
So in that case, what will be the determinant of this matrix then? Can you tell me in this case what will be the determinant of this matrix K time A?
Sir, K to the power 3
K cube A, sir.
K cube determinant of A.
Yeah, what is the property? Because the property tells you, as you've seen in the determinant, having some three types of operation, elementary operations, something is written there. So the first one is this, the first one is changing the interchanging the rows. The second one is multiplying a row with a real number. So in that case, if it is happening, so multiplying a row with a real number, so determinant of this whole matrix is, it will be like this will treat as a single row. This will treat it a single row. This is treated a single row. So you will take common from the first row K, common from the second row K, and common from the third row K. That's why I'll come to the K time determinant of A. This will happen. That's why when you are multiplying a scalar with a matrix, this will happen.
Okay, thank you,
Determinant will be the K cube of that is the order. If it is n cross n order, then it will be come to K power n. It's a general case. For the general case, I'm saying if it is 3 cross 3, then it will come to here.
Thank you, sir.
So this another property will. So what? How many properties here? This one, this inverse kind of, and this one. If you use these three properties, you are able to solve this question easily.
Excuse me, sir. Sorry
sir.
for disturb you. Sir, I think we have to go for the first like concept wise, sir. if our concept are clear, then we can also solve the activity question or something like that.
Okay, okay.
Yes, sir.
Yeah.
I am also thinking like that.
Yes, sir. Like
If
we
you
are
go
wondering
through,
here
yeah,
and there, like
So the thing is like why I'm taking the first this your doubts, because if I will start it, then maybe I will reach to only the system of linear equation, because there are
no
three
issues, sir.
sessions.
No issues. But first, our doubt has been cleared, sir, related to conceptual doubts, sir. And
So,
questions we can also like ask on discourse and something like that. But
so
our
see,
conceptual are not going to solve there, sir.
so see, after clearing this, I will surely, I'm saying that I will take this concepts and will discuss. Why
Yes, sir, 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 sir.
I'm doing this, because somebody's have like he just came to just listen or just ask to his doubt and left the Gmeet. That's why I took like this.
Okay,
Otherwise,
sir. Okay.
so
Okay,
we
sir.
can quickly. I that's why I'm doing very fast. Just he just clear the doubts, then I will start the concept and discuss that. Okay. So we will discuss very quickly your doubts. I hope, but it is not very fast that you will not able to understand. Okay. Pratyus.
Yes, sir. My doubts are solved.
Okay. Okay. Aryan.
Yes, sir. So my doubt is in 1.2 10th question.
1.2 10th question. Okay. Which here is okay. So what's your doubt here? Aryan?
I'm not able to do this question. I tried it, but I'm not able to do it.
So where you are facing difficulty for this question? Like it is the simple one, like suppose your matrix A is given and A square minus alpha time A plus identity matrix. Are you getting each term right? This is A square. What do you mean by A square?
So A square is like A into A. I mean it should be multiplied with it.
Yeah. So are you you are able to multiply
Yeah,
two
sir. Yes, sir.
matrices, right?
Yeah, but I'm I'm not able to do with the alpha
Okay.
thing.
So A square. So no issue. Say find the value alpha is written here. Okay. So what will happen here? My voice is clear, right? Because
Yes,
I'm
sir.
getting message. Okay.
Similar
So
question is been solved in week 1 tutorial 7 or 8.
okay.
If you want, you can check.
You can. Yeah, that's a good thing. That's a good thing. So yeah, just let me just quickly give the idea. So A square you are able to calculate. Just now I told you how you multiply a scalar with a matrix. So I hope you can able to calculate this one also, right?
Yes, sir. Yes, sir. So there are more doubts as well.
So, sorry.
So there are more doubts after this as well. I mean,
Okay, so now and the identity matrix is added. So what you can do, you can calculate the whole this equation. You can calculate in the you will get a single matrix after calculating a square minus alpha A plus identity. When you add each entry according to that, okay. So this is only the of order 2. So this you will get. This will contain something. The first entry will contain the, as you can see that as added the entries. Okay. And this is exactly equal to 0 means 0 0 matrix. So you will get a simple equation and from there you can get alpha. That's the idea. Are you getting?
okay, sir.
So try yourself. Otherwise, there is a tutorial on that.
Sure,
I just
sure,
given
sir.
the idea how to solve that.
Yeah. So my next question is in 1.3 9th and 10th question.
1.3. 10th question.
Yes, sir.
Okay. What's the doubt there? So this is the question.
Yeah.
So suppose there is another system of linear equation given like this. So for some real number, some real values of m and n, find the this value. Means need to find the value m and n. If you are able to find that, that's all. So using these systems, these two system, you have to create a system of linear equation, because see that these two systems, this one is given a system of linear. Suppose there is another system of linear given by this. So using these two, you have to manage it. So how you will manage it? How you will do that?
Sir, may I say something?
Yes.
Yeah, if we consider x1 and x2 as x and y and solve it as a linear equation, like intersection of two lines, and we can get the point x and y, and then we can replace the values there.
Yeah, that's all. That is the that's the simple. Yeah, that's the another approach. Yeah.
Like there is no need to get into the whole matrix thing.
Yes, yes.
So we can
yes.
also solve by getting all the values and putting the answers.
Yes, yes. Solve these two values. Solve
Yeah.
solve this system. Solve this system. Substitute here and get the value. Yeah, man.
Yeah, that's what I said.
One thing is that, and in other ways,
We can convert this into a matrix and solve it like that.
yeah. Actually, what you can do, see that here is 1, 2. Okay, this left side is, if you see this matrix, this is a multiplication is given. So one time x1, one time x3. If you do the multiplication, okay, similarly as you are able to do the two multiplication which is given in bracket, if you multiply these two, you will get that, and multiply these two also. So what you will see that the first equation can be managed, like you will get the some terms will be the first equation, some terms will be the second equation. So if it is the first, so like some portion of the, like when you multiply, you will get an expression, right, equal to some m. So suppose this portion of this expression is the first equation. So replace the first equation with -5, because this portion is equal to -5. So replace this portion with -5. Some portion is some other equation, right? Some other equation will be. So replace that portion with that one. So without solving that system of linear equation, you can get the value of n. Are you getting what I'm saying?
Yes, sir. Thank you, sir.
Aryan?
Yes, sir.
So this way also you can do that. So I hope Aryan's doubt have cleared.
Sir, I have a conceptual doubt. Can I ask?
Yes. So next one is Sneha. Let me go with that. It will be good.
Okay, sir.
So Sneha want to ask some doubt.
Yes, sir. So my question is related to lecture. I'm unable to understand the cofactor concept that was mentioned in determinant
Yes.
part 2. Yeah,
Determinant
so the sign, something like a sign change is managed by cofactor. So can you explain it once?
Yes. So okay. So let me just keep. We can quickly see that this is the cofactor and written here. Okay. So the process is. So suppose I'm taking a matrix of order 3 cross 3, which is A11, A12, A13, A21, A22, A23, A31, A32, and A33. So this you have matrix. So cofactor means here cofactor for each entry need to be evaluated. E for each entry, whatever the entry you have. So like for this entry, you want to evaluate the cofactor. So what you will do? First, you will find the minor. So how you will find the minor? Just remove this row and this column. So what the entry remain is here? This one. A11, A13, A31, A13, and A33. So this is the matrix you will get as a minor of this entry, right? So so determinant as a determinant of this, what is that in the video? The minor will be the determinant of this matrix. Okay, are you getting what I'm saying, Sneha?
Okay, sir.
So minus for this entry is this one, and now cofactor is what will be cofactor for this entry is. So if you are saying I am writing here cofactor or A, I am bigger A I am writing. So cofactor of this entry will be, so it will be 2, 2. Suppose this is 2, 2. So I'm just denoting cofactor, which is A22. So A22 equal to -1 to the power 1, sorry, -1 to the power this portion, this, whatever the written here.
2, 2, right.
2 plus 2, I plus j, right? What is written here? I plus j. And now the determinant of this matrix. This will be your cofactor of this entry, for this entry. Similarly, suppose you want to find the cofactor of this one. Suppose this one. So what you can do, you can cross like this. Now, so this is your matrix. Determinant of this matrix will be this one. Okay, this is A12, A13, A22, A23. Okay, and now let's say this cofactor is A. So cofactor will be exactly the entry, this one, this 3, 1. This is equal to -1 to the power. Now I plus j, this is I and this is j, your 3 plus 1. The sign will be 1 minus 1 to the power 4 and determinant of this matrix. So this is going to be 1 and determinant this one. This is going to be 1 also and determinant of it. So getting that?
Yes, yes. Sir, so in this case, we are getting out all the minors for all the terms.
All entries, yes.
Okay. So the second question I want to ask is 4 by 4 matrix concept I didn't get. How,
So,
because, yeah, how to solve for a 4 by 4 matrix?
So suppose you have a matrix of order 4 cross 4, because you are studying the matrix, determinant of matrix. So matrix will be a square matrix. So
Yes.
just 1 minute. I don't know what I am discussing here. This concept, all of you are getting or not getting that? Can you tell me that? All of you are getting? If you are not getting, please say me. I will repeat it again, and not only repeat, I will start from exactly what is matrix and what is entries, what is minor, what is cofactor.
We get that, sir.
Okay, so if you have matrix of order 4 cross 4, so for general case, each time the best thing is just assume that your matrix is A11, A12, A13 and A14. Like that, you can assume. So suppose this is now A41 and this is A44. Okay, entries are, you can assume that it will be, the numbers will be like that. So this is a general case, assuming to be a 4 cross matrix. Suppose the question will be like that. For in activity question, you have seen that just given a matrix A and not given the entries. So to solve that particular question, you can assume that A is exactly equal to this general matrix, whatever the order is given. You can assume, okay, if A is order 3 cross 3, assume that matrix is this one, general case. If it is 4 cross 4, assume that this matrix is your. And now try to solve that question based on that.
Okay.
But is
So
with the to equal to sum of the minors. Vidyavrat is asking, is cofactor equal to sum of minors? No. Cofactor is exactly what I just given the here. Not exactly equal to the sum of minors. Okay. So yes, Sneha.
Sir, I was asking how to proceed with the 4 by 4 matrix.
So I just said, okay. So the process is same as you proceed with the basic thing is of order 2 cross 2. This is the basic thing. Now when you come to the matrix of order 3 cross 3, so sir have told you the approach how to get the determinant of it.
Yes.
So he told that, okay, take this, just expand the whole matrix according to the first row. Okay. So what he did, this one, and he took A11 and then determinant of removing that one, a cofactor, sorry, cofactor of it. Determinant, that is determinant of cofactor. No, sorry, what is that? Into cofactor, right? That's the, yes, cofactor means this one. This cofactor is Cij. Okay. So the determinant of this one is this one plus A12, then cofactor. Okay, sorry, some minus is there. Is that?
No, cofactor is already taking care of that minus sign, right?
Minus. Okay, no issue. Okay, thanks. So A time cofactor, A12 plus cofactor plus A13, that cofactor. Minus that cofactor will take care itself, the term minus or plus will be here. So this is the process to expand to get the determinant of matrix, right? So let me write that, maybe it is, all of you are not getting that. So what is the process to get the determinant of this matrix is, take A11, now remove this row and column. So what will be the determinant of it? So cofactor means -1 time, what is here, ij is 1 plus 1, here is A11. So I and j is 1 plus 1, and minor determinant of, sorry, minor is called itself determinant, I think. What is the proper word is, let me see that. How sir is saying the ijth minor. Okay. So, and minus this -1 to the power I plus j, and then minor. So minor is exactly determinant of this matrix. A1, sorry, A22, here is 2. So A22, A23, A32, and A33. Then after, plus A12 minus 1 to the power this Aij. So Aij is 1 plus 2. And this minor. So minor will be, now you can remove this one. Okay. And this one and this one. So you will get A21, A23, A31, and A33. Okay. Now then plus is A13, and as you can, very similarly as you can do that, this one and this one. So this is the process. The same process for 4 cross 4 matrix. What is the process here? You will take this A11. Okay. Now let me mute to all of you first. There is some background noise. Okay. Now A11 plus, now what you
Minor.
can do? Minor, sorry, cofactor will come. Right? Cofactor will come. So cofactor, what will be the cofactor? Cofactor will be like this. Okay, you can remove that. So it will come the 3 cross 3 minus, it will be like this, -1 to the power 1 plus 1 determinant. So determinant, not exactly, sorry, minus, so minor will come. So minor will be determinant of that 3 cross 3 matrix you will get, right?
Yes, A22, A23, A24, like that.
You will get a bigger determinant of it.
Yes. 3 by 3 matrix.
Yes,
so 3 cross 3. So now you have to find the determinant of that 3 cross 3 matrix. After finding that, you will get the first one. Now plus A12 minus 1 to the power 1 plus 2 as ij. Now determinant of that minor is, as he said. So minor you will write that. Like that you will proceed for the first row. That's the you corresponding to the first row. This is called finding the determinant corresponding to the first row, or expanding the matrix with respect to the first row. So like that you can proceed. Then 1 3 and 1 4. Right?
Sir, like this, we have to get the 3 by 3 determinant separately, and then we can.
Then yes, multiply and do that and get that.
Because before we were getting the determinants by simply alternatively giving the signs and multiplying with each term of first row and eliminating the row and columns of that particular element. And all others we were taking and multiplying, and that way we were getting the determinants.
As you are doing for the third 3 cross tree, very similar to the fourth process, just the induction of the third, like induction definition is given, sir, is given, term uses induction something is there, I think.
By this formula, we don't have to take it takes care of the alternate signs we have to take for each term, right? Like first one should be positive, so second one should be positive, and all.
So entries will decide that. If you minus to the power this one will do, that entry will decide that the what will be the sign of it. Okay.
Okay. Sir, last question. Where can I find the resources from instructor?
The tab is given here. Supplementary content, in the supplementary content. Okay, here is not. Okay, in the big one, there is one tab. Solve with us. Okay, maybe in the here in the first one have. Okay, there is no resource from instructor. In supplementary content. Okay, one tab will be created if a source from instructor will be there. Otherwise, each thing you will get, like if you want to PDF of this, it will be given to there.
Okay.
And other things.
Okay.
Okay, Sneha. Now, Vidyavrat.
Yes, sir. Activity 1.1 question 8.
Activity 1.1. Question number 8.
Yes, sir.
Okay. Question number 8. Let's do quickly. Okay, this one.
Yes, sir.
So what's doubt here, Vidyavrat?
Sir, in option number 4, V1 represents a scalar multiple of B.
V1 represent a scalar multiple of B.
Yes.
So where is V1? V1 is this one and B is this one. So what's the doubt? Like, what is the problem here? Is that representing or not?
I marked it correct.
Okay, but this is wrong.
Yes.
So how you are sure that this option should correct?
If we multiply by a negative number.
So, but if you multiply with the negative, but you are getting this B1 is on exactly, or maybe this B is on exactly the same line as B. Is that, are you looking? Is that?
It's not clearly visible. I think
Excuse me, sir.
Yeah, hi.
Sir, I have a same doubt regarding the same question about A plus B. I mean, how to know that V3 or V4, which one be A plus B?
Yes, I have this doubt also.
Okay. Okay, so see, it is not that much difficult. Just 1 minute.
Hello.
Yeah, hi.
Yeah, hi, sir. Actually, sir, I joined, sir. So can I ask a few general questions, sir? I have dot in the same question also.
Okay.
But before that, sir, could you please clear that what is this scalar multiple? Means we are multiplying a matrix with the same matrix. That's called scalar multiple.
Okay. Okay. I will tell you. Okay, I will tell you. Or what's your general doubt?
Yeah, sir, this is a general dots, and if, sir, it would be better if you just go through all the options. Sir, means why this option is right and why not, because I also faced the problem in this question, sir.
Okay, so the all option will be cleared, only the word scalar multiple. So let me go with the this by making a suppose all of you know the what is vector. Vector, sir, is said. Okay.
Yes,
So
sir.
simple
Yes,
thing
sir.
is simple thing is if it is something is given, some information is given in some rows and column wise in some array form. So particular that row you can think as a vector. So in R1 means in our real line, in real line, this is suppose 0, this is minus, sorry, this is 1 here, and this side is -1. So this also you can call as a vector, but the vector is only a single number. But when you come to R2, what do you mean by R2 means? It will come as a x-axis and y-axis, and a point, if you denote some point you want to denote, it will needed two coordinate from x-axis and from y-axis. Suppose this is 3 and this is 5. So the corresponding point is 3, 5. So this point you can call as a vector, and you can think it as like this 3, 5, or like this 3, 5, or maybe in this form also. Okay. So however you want to denote it, no matter in this row wise matrix or in column wise matrix or in this form, in this fashion, if you want to denote it. So you can denote. So this is a single vector in R2. Okay. So saying to be like here, this vector, I am saying this vector, suppose this is -2 or -2 and this is 2 here. So this vector could be this. So you can 2, 2 you can say, and or maybe 2, 2, like the -2 and sorry, -2 and 2, -2 and 2, like that you can say. This is a vector. Okay. So representing this is a general representation of a vector. So suppose
to R2 represent the dimension, like here to be.
So when you come to vector space term, then you will know that this 2 represent dimension of the vector space R2. So R2 means here not dimension here. R2 says R cross R. Sorry, I said wrong. R2 means R cross R. Okay, that is called.
Like I mean to say like 2D, like for 1D.
Cartesian product.
Cartesian product.
Yeah.
Sorry, I forgot the name. Cartesian product. This is called Cartesian product. So R cross means this R2 means this one. So actually this one forms a vector space. When you come to the vector space term, this forms a vector space of dimension, a vector space of dimension 2. Okay. So we'll know that that's not issue. R2 here, R2 means here x coordinate and y coordinates for this vector space to understand this, sorry, this vector. So this represent a vector, you can say, you can line it here. So vector means it will start from 0. Like suppose you are saying vector, sorry, let me erase it, and I am saying vector 8, 5. So this vector, or if it is in matrix form, I'm writing this vector 8, 5. Suppose this vector is here. So 8, 5 means if you geometrically, if you want to denote it, so you can write like this. Okay. Now if this vector is here, okay, suppose I am multiplying with 2. So multiply by 2. Okay, this vector, let me write here. Multiplying this vector 8, 5. So how you will multiply? This is called scalar multiple. Multiplying 2 with this vector means this is called scalar multiple. Like you have this vector, I am multiplying 2 here. So whatever u vector you will get the vector. So when you multiply a scalar with a vector, you will multiply each entry, as in matrix you can see. So this is 16 and this is 10. So what you will say, you can say this vector is multiple. What is the word here uses? V1 represent a scalar multiple of A. So suppose this is A here, this vector 8 5 is A, 8, the vector A is 8 5. So this vector, so this V1, so V1 is scalar multiple of A, right? And what is the scalar multiple? I just multiplied 2 here. So you can say V1 is scalar 2 time, or in the word 2 time scalar multiple of A. So got right? What do you mean by scalar multiple? And scalar is actually the real number. You are multiplying a vector with the real number, that real number. Okay.
So sir,
now
can we
when
say
you
that
multiply this vector with 2, so you will get, suppose here is 16, this point. Yeah, continue, you can. Yeah, please ask here whatever you want to ask.
sir?
No?
Yeah, sir. So I am saying
Okay.
that can we say that if we multiply any vector and whatever output will come, that is the scalar vector?
Yeah, scalar multiple of this vector is a scalar multiple of this vector.
Okay.
Okay.
Okay, sir.
Now geometrically, now I am saying here, so after multiplying or getting a scalar multiple of this vector is this one you got, which is 16 and 10. So how it will lie?
Sir,
See, our
in
original
this case, only the magnitude of this vector will get doubled, but no changes in direction.
Direction will not change. That's the main. So what, see, this tells you the direction. This is saying a kind of direction. So direction will not change, but magnitude will change. So see that when you multiply, it will lie in the same direction. But yeah, that length of the line is bigger one to the previous one. So if you multiply with half, this multiply, scalar multiply with this half, so it will be reduced here. So it is 4 and it is 5/2. So it will lie in the same direction. So 4 will be somewhere here and 5/2 will be somewhere here. So it is 4 and 5. So it will lie in the same direction, but this will be. Got the point? What do you mean by the scalar multiple? So this is the geometric approach, geometric view of the saying to be the scalar multiple of it. So what I mean to say, if this vector is, yes
sir, but if we multiply a negative number, a negative scalar quantity, then the direction will be changed or not?
Yeah, direction will be changed, opposite direction.
Okay, yeah.
If it is in this direction, then direction, see that this is exactly the opposite direction. See, you have studied the math one. So representing a line like this, always it will be like this in the both side, right? So this is this line. So a vector very similar to the same. I am saying the same thing. If this is the vector here, so opposite direction in the same line, it will be in that opposite of it. So suppose this is A and B, this vector is here. So suppose I multiplied with -1 here with the same magnitude, the length will be the same, but in opposite. So -A, -B will be here. Suppose I multiply with the half, means this whatever so this is, suppose this is V1. Now another, sorry, this is A here, or so V1 obtained scalar multiple, which I am multiplying scalar is 1/2 and AB. Okay, so V1 we obtain this one. So what it will be? It will be the length will be reduced here, but the direction will be the same. So it will be here somewhere 1 by 2 A and B. Getting?
Yes, sir.
So
Sir,
now
please
I
repeat
hope,
this. Please repeat this.
if it is negative,
Repeat this.
suppose this is minus 1 by 2. So it will happen? It will multiply this minus 1 here will come, and now 1 by 2. So you already got, I just wrote here minus A minus B. So opposite direction with the reduced length. So it will be here.
Okay.
What about addition of two vectors?
Now addition of two vector is different. That is called parallelogram rule. What is a parallelogram? In that video lecture have done, is that?
Yes, sir. It's there.
Adding two vector is in this fashion will be added in the parallelogram form. So this is it. So let me tell you that idea also. So suppose you have two vector. Now suppose this is a vector and this one. These two vectors are here. Okay, these two different vectors. Let's say this is v1 and this is v2. So when you add that v1 plus v2, so what will happen? So let's say v1 is ab and v2 is a prime b prime. Okay. So when you add these two vector, what will be the obtained vector will be? Let's say I am getting v3, which is v1 plus v2. So this is, we are studying this vector in R2 or maybe R3, whatever the vector is said here, because you till now you didn't study the vector space. So that means if you are adding these two vector means just add coordinate wise. So vector will be a plus a prime, b plus b prime. This will be the third vector. But if you see it in geometric way, it will be look like this. So v3 will be here somewhere. Okay, but how it is obtained? It will be that it is saying to be like this. Because you added, what is happening here? This line is parallel to this line, and now this line is parallel to this line. This line is parallel to this line, and this line is parallel to this line. So geometric view of the adding two vector will be look like that. What is happening here? The thing is, if you want to reach this vector, so take a parallel line of it, parallel vector from here to here, and then you will reach to here. So this is just a visualization. Otherwise, numerically it is given. So you will add a coordinate wise. Okay. I think many of you didn't get. I think I didn't explain properly.
No, sir.
Yes, sir. It's clear, sir.
Well, sir.
Am I audible, right, to all of you?
Yes, sir.
Excuse me, sir.
Yes, sir.
Sir, but
Sir,
in a
actually-
question, sir, it's
Yeah,
given
you can.
V3 and V4. Then how can we know that which one will be the addition, representing the addition?
Can I answer this? Sir, are you talking about that 1.1 question number 8?
Yeah, I think the same question, I think.
Okay. So just because if we add vector A with vector B, then we will get 1 and 0. The coordinate of that, I mean, that the new vector will be 1 and 0. So the y coordinate is 0. That's why B4 will be the answer. B3, in that B3, the y coordinate is not 0. It's lying above x-axis. That's why I think.
Oh,
Yeah,
yeah. Thank you.
that's the answer. Yes,
Yes, sir.
that's the answer. So what I am saying, see, this is just a visualization, and the process to adding to this what I added here, the visualization of this vector is we are adding. This is called parallelogram rule. What is happening here? I took a vector. This if you want to add these two vector, okay. Let me erase it. If we want to erase these two vector, so what you will do? You will take a parallel line which will be parallel to this one, this here, and parallel to this one, this vector, to take two parallel vector where they will cross. That would be the addition of these two vector. But numerically what you use, that just add a coordinate wise. That's the happening. Okay, so as here it is given, a is given -1 2 and b is given 2 -2. So a, what will be the vector a plus b? Just add it. When you add a plus b, you will get 1, and this you need to add 2 and -2, which is 0. So addition of a plus b will be 1 0, right? Coordinate wise addition we will do. Okay, let me write here. Our vector a is -1 2 and b is 2 -2. So now if you want to add, so what you will get? Coordinates wise addition will do. Let me write in matrix in this fashion. If I'm writing here -1 2 and this is 2 -2. So -1 2 plus 2 -2. So add coordinate wise, so -1 plus 2, 2 -2, so which is 1 0. So a plus b will be 1 0. If in this fashion if you want to write, so a plus will be 1 0. Okay, so a 1 0, where it will lie? It will lie on x coordinate, right? Because the 1 0 1 is non-zero, and but the y-th coordinate is 0. So somewhere it will be here, right? What I'm saying is that clear to all of you? No? Yes? So please comment.
Yes, sir. It's clear.
Yes, sir.
Yes, sir.
Yes.
Oh.
Sir, activity question 1.2, question number 6, sir.
Sir,
Yes, yeah.
sir, could you please take next question in the same activity 1.1? Question number 9.
The same thing is the same thing. So this question is also very similar. The same thing, you have given two vector, just c time a plus 3 time b and added that. So it is given 4jk. When you get these two, you will get a simple equation in one variable and write the value of c, j, and k. That's all. I will just give a hint. You have to do. I just give a hint. Getting know what I'm saying? See, you have given a. Okay, a is given some vector. Now ca is given. So what will be, sorry, ca. So ca means you are a scalar, you are multiplying a scalar with the vector. So each entry multiply with the c. B is given, and b, the second b is some 3b. So each coordinate multiply with 3. Now add them, coordinates by addition you will do, and this is given right side as 4jk. Equate to them. If two vectors are equal, let me that. Okay, if two vectors a and b are equal, what do you mean by that? If it is, this is, let's say a11 a12, vector a is a11 and a12, and vector v is, let's say, b11 and b12. Okay, if these two vectors are equal, that means a11 equal to b11, a12 is equal to b12. Coordinates wise equality will happen. So just do the coordinate wise equality. You will get a, c, and j. Sorry, c, j, and k. That's all. This is a simple equation. Clear? Okay, am I audible? Oh.
Yes,
Am I audible to all of you?
Yes, sir.
Yes, sir. Yes, sir.
Okay. Okay, now I'm taking the next one.
Question 1.2.
Ravikant, yes.
Yes, sir. My doubt was on activity 3, question number 9.
Activity 3, question number 9.
Hello.
Okay.
Hello.
Yeah. Yeah. Hi. What's your name?
So, am I audible? Hello.
Yeah, you are audible.
I'm Sneha. So, can you explain the coordinate wise you are saying? That means A, B, C, D, whatever that you mean that, right? Coordinate wise.
Coordinate wise means I am naming it coordinate. Okay. Coordinate wise means so maybe these entries are I'm saying coordinates. Okay, these entries. This is first coordinate. This is second coordinate. This is first coordinate. This is second coordinate.
Okay.
So if you are confused with the coordinate word, so mean to say the entries, corresponding entries.
Okay, so in first activity, first question, level 1. So coordinate wise means each first entry should be multiplied by first entry and second entry should be multiplied by second entry.
Each entry is multiplied with that scalar.
Okay.
Yes, Ravikant, which question number?
Thank you.
8. 8, I think. No?
Question number 9.
Question number 9. Okay. Okay. Consider the system of linear equation this where k is real number. If the given system has unique solution, then k should not be equal to. So, so what's the doubt here? What's your doubt here? Why? What would be the k then, or why? What would not be the k?
Like for I'm not getting it. Like how many it may come there, but suppose for unique solution it will cut. But how will I decide that k? I'm not able to go for the question.
Yeah, determinant should not be 0.
Sir, your voice is disconnecting a lot.
Yes, sir. It's breaking in between.
Internet may hear you. Sir, we cannot hear you.
Yes, sir. It's still breaking.
The best thing is determinant should not be 0. The simple
Sir,
thing.
you are not audible.
If you are adding with that.
Sir, your voice is breaking. Not audible.
Oh, just 1 minute. Let me. Am I on?
Yes,
okay.
sir.
Just.
No, sir. It's still breaking.
Yeah.
Am I audible now properly?
Yes, sir. Yes.
Yes, sir. Yeah.
Okay. Yeah. Now it is sorted. Okay. I hope now my screen is visible, right?
Yes, sir.
Yes.
Okay. So the thing is, the one thing is that determinant. Okay. Let me that. If you have let me suppose a system of linear equation ax plus by is equal to let's say d1. cx plus dy is equal to d2. If these two equation is given, so see this is x and y is given, so you can able to plot. Actually, one equation represent a line in R2. That's the main because x and y you have already gone through the math one and coordinate system. So you can draw the line of it, of this first equation. Suppose this line is passing through like this, and the second equation also passing through like this. If these two lines are intersecting, then the system has unique solution. Okay. If it is these two lines are not intersecting, means they are parallel. Okay. So what do you mean by this parallel word? In this, what is the effect on when these two lines are parallel? What is effect on the numerical? This in numeric like A, B, C, D. What will happen?
It will be proportional or same.
The
Yes, sir,
left,
both,
the left numeric values will be the same. Only the right numeric will be the different. Only these two differences will happen, right? Because as you already coordinates,
sir, also the slope should be same.
Slope will be same means slopes will be the same. So what do you mean by slope? When you do like this, y is equal to something, it will be what will come? Something will come and the both have the same slope. So mean to say the left hand whatever the A and V will be, and C and D will be, the possibility that C and D will be the some multiple of A and B. It will be some k time A, okay, k time A and k time B. Exactly will be the same. But this side will get, when you divide with k, then you will get k ax plus by some d2 by k. But these two will be different. It will be not same. That's the mean by parallel. Getting everyone?
Yes.
That's the mean by parallel. So now I hope you got the idea what will be k here. Right now, what for the given? What is the question? If the given system has a unique solution, then k should not be equal to. So if you want a unique solution, then what would be? Can you tell me that?
Minus 3 because minus 3.
Minus 9.
Minus 9. Yeah, minus 9. Correct.
Yes. So that's the mean here. That's the mean. This is the mean by this parallel line unique. No solution case. And infinitely many solutions. Let me tell you again. For infinitely many solutions.
Excuse me. Yeah. Even if it's like proportional, then also the line can be parallel, right? Suppose if they're in the first equation, can you show the question? Like suppose in the first the coefficient is 2 and 3, and in the second equation it's 4 and 6. So it's like proportional to the first. So even that time it will be parallel, right?
Yeah, parallel. That's the I said. If it is, then in that case, C will be k time A. Some D will be k time some k time B. It will be like that. This is the proportional, right? This is k time something.
So, but here k should not be equal to 0.
K should not equal to 0. If in that case,
because we want a unique solution.
No, for the no solution case, I'm saying k assuming to be k not equal to 0. In that case,
so for infinitely many solutions also k should not be equal to 0, I think.
No, k can be in that case 0. I will tell you. Okay, I will.
So, sir, if k will become 0, then it is not going to be an equation.
Okay. Sorry. Okay. If it is like right side is not 0, then
D2
k will
is
not
not
0. If
equal
it
to
is right
0.
side is 0, then k can be 0. K can be in that case 0.
K can be 0.
So if a system has infinitely many solutions, what would be in that case? Suppose I have a system, this one, the same. the same system. This suppose I have a system of linear equation. This one, okay. Okay, so this one I have. So in infinitely case, so I draw the first okay, same here. So suppose this line represent this equation represent this line, and this line represent suppose this line. Okay, if these two are intersecting means unique solution. Now suppose when you draw the first equation, you got this line. Now the second one, when you draw the second equation, it will exactly the same line. So in that case, this system has infinitely many solutions. But what is the numeric differences, or what is the numeric relation in these two equations? What will happen here?
One equation is k times multiple.
Yeah, exactly the k time.
Another.
This equation will be k time exactly.
Yes, sir.
Exactly
on the both
the
sides.
first, both sides. That then it will be the
So, sir, like if we extend this idea and try to understand what is the physical significance of determinant, right? So, like when we have a matrix, and if we look at the column wise, okay, so columns are nothing but stack of different vectors, right? Okay, so now can we define like what is the physical significance of determinant in that case? You have
Yeah.
multiple vectors stacked in a column.
So let's see that. Okay, let's see that. So if you want to, yeah, let's see that. So if you want to, the matrix form of it, this system, okay, this is A, B, and this is C, D, okay. So how you write, I hope all of you got the idea how to write a matrix form of a system of linear equation. This is the form. Okay, let me tell you the simple quick way to what do you mean by this, or how to write a matrix form of system of linear equation. So the thing is, see, whatever you form wrote here, if you want to verify, I just exact the same form, just multiply, because this is given as a multiplication form, right? So just multiply with this matrix. Sorry.
Sir, the question is little bit different. Okay, say for example, you have a matrix. Okay, now you have 4 vectors v1, v2, v3, v4. They are stacked in a column. Okay, now like a couple of slides back, like we discussed about determinant, right? Okay, so my question is like, what is the physical significance of that determinant?
So yeah, I just that's I want to tell you. Let me finish that. I was just given the how to write a system of linear, as how to form a matrix using the system of linear equation. Okay, once you got this, okay, so this matrix will help you to decide unique solution, no solution, or infinitely many solution. Okay, what is the significance, as you said? So see that the first case we took no solution, sorry, unique solution. So okay, the first case was unique solution. Okay, so when it have unique solution means what? When you get the determinant of this is called coefficient matrix. Calculate the determinant of it. It will be like this: AD minus BC. Okay, if this AD minus BC is not equal to 0, what do you mean by that? AD minus BC. See here, AD minus BC. This is A here, and this is D here, and this B, and this C. Okay, this is what we have. Okay, so here is not, we are not able to relate here. For the no solution and infinitely solution, you will see that here. Okay, so let me write the another one: A, B, C, D. And this is the case for no solution. I am writing no solution. Okay, this is the case for no solution. So when you try to get the determinant of this matrix, it will be AD minus BC. For the no solution case, what will happen? Still you will get the 0 determinant. Okay, just 1 minute. Actually, I want to try to with this relation. Just a minute. Okay, for no solution, the help is from here. Okay, these things are will be decided from when you come to the Gauss elimination. Okay.
Yes, I think it's there in week 2.
So in Gauss elimination, see, for the no solution case, this right part of the equation playing role. That's why this determinant is not helping us. So it's difficult to get the significance like in row wise, as he said that we are stacking it in a row and try to get that. So here when you learn the method Gauss elimination, right? There you will see what is happening with this row, sorry, these columns. So actually what will happen, right? When you do the Gauss elimination, there you will for the no solution or infinitely solution, you will form this system in the augmented form, which is writing like this. Okay, I am just being a brief of there what is happening. Augmented form, you will change this matrix in reduced row echelon form, and there this D1 and D2 will decide that system has unique solution, no solution, or infinitely many solution. But whenever we are getting the determinant as 0, I don't know, is this taught in this week or I am just discussing? No?
No, sir, it's not.
So no need to, no need to, oh, sorry for, so no need to talk. So I'm not going to discuss this one. Oh, I forgot to. This is the next week. Okay. So for this time, to know that.
But sir, what this AD minus BC, what it physically means actually? Is it the area enclosed or like
No. So
volume enclosed? Any physical significance?
So you will see this when you come to the Gauss elimination method. Then you will easily say that what is happening here, what is happening there. Okay, so please wait till that time, because this is not taught in this week 1 and many of you are here for only week 1. So I think this is not a good place to discuss that. When you will be there for week 2, surely I will tell what is happening there. Okay.
Sir,
yeah.
Hello, sir.
Yeah.
The question you discussed lately, which is 2 equations, both of them are same.
Yes,
So,
yes.
if we draw a line which is parallel to y-axis, then it will have no solution, or still it will have infinitely many solutions.
No, in that case, no solution case is only. No, these two lines are not intersecting. So there is no possibility they are not intersecting, means they don't have a matching number, same number.
No, sir. My question was like, we have a equation, and we have one equation, and the second one is the multiple of it, like k times of that equation. So it will overlap each other, right?
This is overlapping. That what do we mean that it have many solutions.
Yes,
whatever
sir.
the points are there, all are satisfying both equations.
And now I give you a third equation, which is parallel to y-axis.
Which is parallel to, okay. Now the third equation is which is parallel to parallel of it. This okay.
Y-axis, sir. So it will intersect both of them.
Oh, okay.
Yeah. So it will have no solutions or infinitely many solutions still.
So this case, what I just made it here. In this case, like 2 lines are overlapping and another one is intersecting. Is
okay,
that?
It means yes, sir.
Okay, let me tell you. If
Sir,
it is
your voice
happening,
is breaking in between.
okay, is it now?
But I
fine?
can hear it, sir. I can hear you.
Fine.
Okay. So let me tell you the cases here. If you have like this, suppose these 2 lines are you have 3 equations, let's say, yeah, this equation, this equation, and corresponding lines are here. Okay, for this equation you have this line, for this equation you have this line. The third one is like this line. Okay, suppose these 2 are parallel, and these two lines are parallel. Okay, and the third line is passing like this. So see that, what do you mean by have, what do you mean by unique solution? Means all three line will intersect at the same point. If it is any one of them is not intersecting at the same point, then that system has no solution. Only the case is here. If all three lines
I have a stat 2 session on 8 p.m. So may I have?
Okay, so your doubt is got cleared or not?
And not yet clear. Actually.
Okay, so okay, so Shivani, okay, you can ask now itself. You can, or maybe you can move to the stat 2 because it is 8 now.
My concept is, my doubt is not specifically. I have concept doubt.
Okay, conceptual doubt. Okay.
Yeah.
So the thing is now, then you can.
Maybe you can explain her. I can wait for. I don't have stats.
Just now, see, if you have time, we can discuss this. Otherwise, we have to then come to the next session. That's the thing. Or you can ask in discourse also if you don't have time. That you can ask there your doubt in discourse.
Tomorrow we have open session, no sir. In that also maybe she can ask.
Actually, today is the totally on activity on practice. That's why I took the questions. Otherwise, open session. The thing is, we plan to like this. First, discuss the concept, and then. But today, 30 minutes I spent it just on the briefing. That's why I didn't started with the concept. Otherwise, the process is I just took the concept, take half of the concept we'll discuss, and then your doubts will be discussed. So from the next session it will be like this, continue with this one. But because I spent 30 minutes on the different thing, that's why I didn't start with the concept or the concept thing. I just jumped to your doubts. Otherwise, when I will take the next session, I will first discuss the concept, then we'll discuss the doubts. From the next session it will be like this. So okay, so the thing is, if you have three lines, the only have unique solution when all three lines will intersect the same point. Otherwise, if anyone is missing from the any place, or then it have no solution. Okay, and for infinitely many solution, all three will lie or overlap. All three line will overlap. Okay.
Okay, sir. Sir, I still have that doubt. Like, we have two equations. First one is something, and the second one is the multiple of it, and the third one is intersecting both of them. So then what will?
So in that case, have so the case is here. You have a line, and the first equation, and second one is on overlapping, and third one is intersecting.
Yes, exactly.
So in that case, see that all three lines are intersected at this unique point. So it have a unique solution.
Okay, so got it.
Okay.
So even though we have some cases like we take three equations, but each two of them are have common points at different places.
But the third one is at different place. So in that case, no solution will happen, right?
Yes, sir. It's like a triangle. I mean,
it is like that.
Sir. I mean, in week 2, we will know how to find like this equation have no solutions. This kind of equations.
So in that case, if it is like this happening, then see, what do you mean by unique solution? Means you are getting a point which satisfies all three equations.
Yes, sir.
If it is you are not getting that, then there is no solution.
Yes, sir. So, but till now we are just finding it by looking at the equations, like whether they have they are like parallel or they are overlapping situation. But we don't know about this scenario. What you have drawn right now, that triangular shape. Yeah.
So in that, okay, so for this triangular shape, the same thing is happening, right? you are getting not a unique point. You are getting a different. For these two line, you are getting solution. For these two line, you are getting solution, but third one is needed. But for the see this, suppose this is the first equation. Okay, this is the first equation. This is the second equation, and this is the third equation. So first two equation you are getting solution, but not the third one, because these two are intersecting. You have able to get a value, but when you are substituting this value into this third equation, you will not. It will not.
Yeah.
That's the thing. That's mean in that case no solution. Similarly, for other case also will happen.
Yes, sir. Okay.
Okay. Okay. So
Sir, activity question 1.2, sir.
okay.
Also join the activities of 5 question number 7, sir.
Vinay have remained. Let me go then astitva have. Okay. So Vinay, which activity?
Activity 5, sir. Question number 7, sir.
Sir, I had one more doubt, sir.
Okay.
Like
What's your doubt?
Like in activity 4, question number 4, I was able to solve according to the formula, but
सबमिट भी करना
like question number 4.
Okay, this one.
Yeah, I was able to solve, like I solved this question using like the expanding, but is there any property, like can we solve this using any property?
Yeah, that's the purpose is given here to solve. Let me mute all of you. Only Ravikant can. There is some background. Ravikant, you can unmute yourself. So yeah, this question is given for the purpose of the third property of getting the determinant.
Can you explain, sir? I guess I didn't come across this in the lecture.
No, so see that what is happening. The second row is t time the first row, exactly the first row, minus s time the second row. So what will happen then?
It will be some element like subtracting t times say and then r times of the root third, right?
It will remain unchanged.
No, I guess. Hello, sir.
Yeah, I'm listening. I'm just listening. Can someone help to solve this?
I guess
Yes,
it's that
sir.
property, right?
Sir, we can make.
So in the third row, we can call common the R, and any of the expansion you want to the row and column, you got the determinant of this question.
Yeah, we can do using that, but I guess if
Sir,
there's
we
some
can make
property-
the second row 0 by.
Yeah, that's all. That's all. That's the answer. You can make it second row 0. How you can make it? You can subtract the second row from the second row using t time, right? T time the first row. Similarly, you can add the third row in the second row. Using these two, you can make the second row 0. And if a matrix have a whole row, like the row is 0, then the determinant is 0.
The determinant should be 0.
Yeah, that's the answer here. Getting?
Sir, or we can do one more thing, like we can make row 1 and row 2 same. Then in that case, the determinant
Also,
will.
yeah, correct.
What
What you can do?
Will
Yeah.
R taking out as outside, then I mean R from the third row, and then we will just add. We will just multiply T with first row,
And then yeah, correct. That's also the way.
Yeah, and sir, in practice assignment question number 3, there is a statement like if the sum of the first and the third row of vector of 3 cross 3 matrix A is equal to the second row vector of A, then that equals to 0. Can you like It was in
So,
practice.
so that's the same thing. Which practice? Which
Yeah,
sorry,
practice.
which
Question number 3. Question number 3. Last statement. Yeah.
Okay, this one. If the sum of the first and third row vector of 3 cosy matrix A is equal to the second row of A, then determinant is 0. This is the exactly same the whatever the activity we are solving. So what is this option is correct or not?
I don't know because they will give the answer after the deadline.
Okay. Okay, so think they're using the same activity and let's see that. So now you can try this option. Okay.
Hello, sir.
Yeah. Hi. Yes. Yeah, Vinay.
Activity 5, sir, question number 7. Just explain the option 2, option 3rd.
Activity 5. Question number 7.
Yes, sir.
Okay, this one.
Yes, sir.
So what is difficulty here? Vinay?
I not found out the determinant equal to 6, sir. How?
Okay.
What are the approx-
So are you able to create are you able to get the whole matrix A?
Yes, sir. Yes, sir.
So once you get that, then it will be upper
I
triangular.
get the option first is correct, sir. A is the upper triangular matrix, sir. Now I not found the option C, sir.
Okay. What is the matrix A? Can you tell me that? What would be that matrix A?
So J at place now, sir. Because if I is greater than J, then we put the 0. If I is less than or equal to J, I put the J.
So is that it will be upper triangular or lower triangular?
Yes, sir. Upper.
It would be upper triangular.
Yes, sir.
Okay. So it would be upper triangular. So determinant, what will be the determinant? Determinant will be exactly the multiplication of diagonal.
How, sir?
Okay. So let me tell you that. Suppose you have A11, A12, A13, upper triangular, this is right. A22, A23, this is A33.
Yes.
Okay. So this is upper triangular. So if you want to find the determinant of it, what will be then? The same process, A11 and erase this 2. So you will get this matrix. Okay. Determinant of this matrix, A time determinant of this matrix.
Yes, sir.
So if you multiply these two, what you will get here? See, these two, it will be A22, A33, and this is going to be 0, right? Now A12. Once you take A12, so what would be then? Determinant of 0.
Yes, sir.
Now rest is 13. Determinant will be similarly, we will get 0.
Yes.
The final thing is A11, A22, A33, exactly the multiplication of diagonal.
Yes, sir. Yes.
Right? Now you can tell or choose the correct option. Clear?
Yes. So, but sir, diagonal matrix are there. Element is so J, na, sir. We put the J only.
It is greater or equal to, then it is J. Yes.
So how we can get the 6, sir?
So see, J time is now changing, right? J is first, what will come? 1. Second will come 2. And third place you will get 3, right?
Yes,
at the
sir.
diagonals. Now multiply that, what you will get? 1 cross 2 cross 3.
Yes, sir. 6.
So it is 6.
Okay, sir. Thank you, sir.
Okay. Now
Sir, I have done
yeah, Deepa.
Sir, I also
1.2 question number 8.
Okay, yeah, I will take one by one. Okay, one by one we'll take. So please raise your hand, that would be good. So 1.2.
Yes, sir.
Okay, which activity?
Question number 8, 1.2.
Question number 8. Okay, so what's your doubt here?
I have doubt in option 4. How we solve this? How we get conclusion ki this is wrong or right?
Okay, use this hint. Are you using this hint?
Yes, sir. I got the four equations, but after that I was not able to get the answer.
Okay. You're using 4 equation. Can you manipulate like something so that you can able to get some matrix using these 4 equations? Can you tell me?
Equations.
4 equations.
A11 square
A11 square
plus A12
A12
A21.
A21.
Sir, A12 multiply with A21
Okay.
plus A11 plus 1 equal to 0.
Okay. The second one?
A11 multiply A12.
Okay.
Sir,
A12
A11 plus A12
A12
multiply A22
okay
plus A12 equal to 0.
A12 equal to 0. Okay.
Sir,
Okay.
third one is A21
A21
A11 multiplied A11
okay
plus A22
okay
A21 multiply A21 plus A21
equal
to 0.
The fourth
And
one
fourth
is
one is A22 square plus A21 A12
A12
plus A22.
A12 and A22.
Yes.
Okay. Plus
No, sir. A12 and A21
A12 and A21. Okay.
plus A22
Plus A22 plus 1 equal to
yes,
0,
sir.
right?
Yes, sir.
So, okay. So, is there anything in these two equations?
Yes, sir. We can take common A12 in the second one.
Yes. So, A12, if you take common, it will be A11 plus A12 plus 1 equal to
Yes, sir.
equal to 0. Similarly, if you
Yes,
take here common A21 common, you will get
Yes, sir.
A11 the same equation
Yes, sir.
equal to 0. So
Yes.
you have these two equations.
Yes, sir.
Now back to here. Okay. So see these two equations here, A12. So see these two are multiplied. So either A12 0 or the whole thing is 0, right?
Yes, sir. Yes.
So assume the cases here. Now it is like that. Assume the case if A12 is 0. If A12 is 0, then what will happen here? In the fourth equation, A11 square plus A11 plus 1 is equal to 0, right?
0. Yes, sir.
This is a coordinate. This is the coordinate I'm saying. Quadratic equation. So if
Yes,
this
sir.
quadratic equation has real solution?
No, sir, because it's an imaginary issues.
Imaginary. So then you have to remove this case. Oh, so we are going a wrong place. So assume that this is not equal to 0. This is equal to 0.
Okay, sir.
And now using this equation, do something. If you assume this one, A11, now assume that A11 plus A12 plus 1 equal to 0. So what will happen here now? This one you have.
It cannot
Okay.
be true because the plus 1 is there. No, but A11 and A12.
It can be. So now see that you have this equation, right?
Yes, sir.
Now multiply with A11 both side. So it will be this. This is A1. Sorry, A11.
Yes, sir.
And A12 plus A11 equal to 0. Now substitute here and it will help you find some value, right? Because this is here, this is here. Okay.
Yes, sir.
So like that you can reduce some equation. See, using this manipulation, you will able to reach something relation in A11, A12, A14 and give to some particular value. and you will get the answer. Like that.
Okay, sir.
Now you can try yourself. Get the idea, right?
Yes, sir.
Otherwise,
Yes, sir.
if you have again difficulty, please post in discourse. We will answer there in the whole solution
Okay,
of it.
sir.
Okay.
Okay, sir. I have one more doubt also.
Okay.
Activity 1.4, question number 7.
1.4, question number 7. Okay.
In the
This
option 1, sir.
one.
Because
Length of
it is given x is greater than 0. So I am getting x equal to 1. If we put x equal to 1 in P and Q coordinate, then I am not getting length of PQ is root 29. If I put -1 instead, then I will get root 29.
Okay. So is that an option is correct or not?
Yes, sir. It's a correct option. That's why. Because sir, I get the third option by putting -1 in Q and R coordinate. But
Okay.
I'm not getting
Is
the
that
first option.
if anyone is here getting like this? I don't think it is like that. Like this. It's not like this. Yeah, maybe you are making some numerical mistake. That's why it's happening. Can you
Because
check
sir,
it?
I solve it 2-3 times, then I'm getting the same. That's why I'm asking.
Okay.
Yes, sir.
No, sir, I am getting the right answer.
Yes, sir. I also getting the right answer.
Sir,
That's why.
can you?
Sir,
Sir,
x value will come as 3, sir.
Yes, sir. Yes, sir.
Okay.
Okay, sir, I will try it again also.
Yeah, then you should to try because this is just a numeric thing. There is no need to know the concept.
Sir, this is the formula given for the area of triangle is it's valid for all the triangles coordinate.
Yeah,
This one, right? Yes, yes.
Okay, sir. That's
Okay. Okay. Ravikant is okay. Deepa is done. Ravikant is also, I think, done. You have, right? Okay. No, it's assist. Assist to have. Sir.
Yes, sir. I'm having doubt in activity 1.4, last question.
Okay, this one. Find the value of this one, determinant of det
I
a
just
square.
wanted to know that which approach we should follow for solving this question. I mean, how can we use this hint which is given?
So you see, this one is given, right? Can you try to compute the determinant of a matrix of this form? This hint is given. So if see, no need to do more numeric thing like more calculation. Can you do it here? Is there any similarity when you apply the determinant property? Those three row operation property. Simple one is, are you able to see that if we add all three, see these two row in the first row, what you will get? A plus B plus C, A plus B plus C, A plus B plus C.
Yes, yes, sir.
So take the common A plus B plus C from the first row. You will get the 1 1 1 from in the
Yes, sir,
first
yes,
row.
yes, I got it.
So like that you can do and easily can evaluate the determinant.
Okay, sir. Thank you.
Okay, Astit have done Dhananjay. Our answer. Yes,
Yes,
sir.
sir. The activity question 1.2.
Oh, before you that, okay, it is
No, sir.
Rajat is there, Harsha and Sahala is there.
Dhananjay is here, sir.
Okay, okay, Dhananjay. Okay, what's your doubt here? Which activity?
Activity question 1.2, question number 6, sir.
1.2, question number 6. Okay. This, which option?
Yes, sir. Option number 1, sir.
Okay, if a square matrix of order 2 happening like this, then where sorry, if you see it is then this one where identity matrix. So it is asking that if A is a square matrix of order 2 and A square is square identity, then A is exactly I or minus I only. Is that?
No, sir.
If you are from starting, then the first question is very similar to like that. If A square is equal to 0, then A is 0. Yeah, this is true for the identity, but is there any different matrix with this property? It is happening like that. This can be possible, right? Apart from identity, if you multiply these two, it will give the identity?
Yes, sir.
No?
Yes, sir. Yes, sir.
Yeah. So that's why you can get that. Can you give an example?
Sir,
Can you
no,
think
sir.
for -1 0 0 1? What will happen there? Can you check and let us know? Let me know. Will that be? Let's see that. Okay. So like that, it can be possible. There is not. It is not necessary that A is exactly identity or minus of identity.
Yes, sir.
Okay.
Yes, sir.
Okay.
Sir,
Okay.
option number 4, sir.
Okay. In the same question. Okay. If A is a scalar matrix of order T and B is a non-zero square matrix, okay, of order 3, then AB equal to 0 implies and AB equal to 0, then A equal to 0. Can you check for making a matrix of A as a scalar matrix and B is a non-zero square matrix of order T? And can you do that? And so okay, you know that what do you mean by why the name of a matrix is scalar matrix? Because it will behave like a scalar. It will behave like a scalar. Why the name of a matrix is scalar matrix? If suppose you have a what do you mean by scalar? What is the
Scalar
scalar matrix?
vertical diagonal is constant, na, sir?
Exactly the same number. Constant. Exactly. All will be the same.
Yes,
Scalar. Okay. So if you multiply with the non-zero, what will happen then? Can you check for this? If you check for this, then you can easily do that. Right? So this is the process we can do. Is that then this scalar is going to be 0 or not? See, scalar white is given, it we have like a scalar. Like, then what do you mean by that? You can just do like this. This multiplication can be think as not exactly. Will be saying to be like this. This multiplication can we say that like this k time this matrix. And then if it is 0, what do you mean by if A is non-zero, then our k is going to be 0, right?
Okay, okay.
That's the name, the purpose giving to the name this is scalar matrix, because it will behave like a scalar. Scalar means multiplying with the real number to a matrix. Okay.
Yes, sir. Yes, sir. I have another question, sir. Activity question 1.3.
1.3. Okay.
Question number 7, sir.
Question 7. Yeah.
Yes, sir.
Okay.
I am unable to understand.
What's doubt here? No. So are you understanding that what do you mean by x1 and x2 is be the solution of system of linear equation? This getting the word?
Yes, sir. Yes,
I
sir.
also have same doubt.
Okay. So
Yes, I
what do you mean by that? If this term is saying x1 is x1 be a solution. Sorry, x1 is a solution of ax is equal to b. What do you mean by this? What you will infer from here?
That means a solution of linear system of equation is x1 and x2.
So what do you see? X1 I am saying is a solution of this one. So what do you mean by numerically, or what do you mean by in this equation form? Can you tell that? What do you mean by saying a solution? Saying a solution means this will happen, right? Ax1 is equal to b.
Yes, sir.
Right? Because see, if it is a system, you want to find the value of x, and this says x1 is a solution of the equation means what? X1 give the satisfying this equation. That's the mean, as you are able to see in the simple thing. Like suppose if equation is given 3x plus 5 equal to 2, and somebody says let's say A is a solution of this equation. What do you mean by it? You will substitute here, right? Substitute here. You will substitute here. Solution of what do you mean by saying to be solution? If you substitute A here in place of x in left hand side, it will give right hand, right? It means 3a plus 5. When you solve it, it will give 2. That's the main saying to be the solution. A is a solution of this equation. Similarly here, if x1 is solution of this equation, which is matrix form of a system of linear equation, that means in place of x, x1 will lie, and this is happening. Like a x1, when you substitute, it will give right side to b. That's the meaning, right? Meaning means saying to be the solution of a system of linear equation. Am I audible?
Yes, sir. Yes, sir. Yes, sir. I understand.
So getting know what I am saying? X saying to be a solution means this will happen. This one, a x1 is equal to b, right? Similarly, says x2 is a solution of this system. What do you mean by a x is equal to b? Now can you check that x1 plus x2 is be a solution of this equation? What do you mean by that? Or one by one you can check, and can you tell us what is happening here? So that's the only thing here. It will answer your now each option. What is happening?
Okay, sir. Okay, sir.
Okay.
Okay, sir.
Okay.
Sir, in the same activity, 8th question also.
Okay. Rajat have doubt. 8th question. Okay. This the same thing is V is solution of ax plus b. Sorry, a1x plus b and a2x plus b. Sorry, a2x equal to b. V is solution of two system of linear equation, a1x and a1x equal to b and a2x is equal to b. The same thing. Can you apply now here the same? It is exactly the same word. What do we mean by V is solution of ax1? Means a1v equal to v, a2v equal to v. Now can you check that what is happening here? If you substitute here b, you are getting right side b or not? If you substitute in place of x v in left hand side, are you getting b or not right hand side? Like that you can check and can answer easily.
Okay,
I think.
okay. Got it.
Okay.
Sir, and I have one more doubt, sir.
Okay, yeah.
Hello.
Which activity or where is that? Yeah, yes, Rajat.
1 second, 1 second. So 9th question.
Which activity?
5th activity.
Activity 6 activity. Where there is no 6.
5th, sir.
Sorry, 5th. Okay, 9th one. Okay, suppose A is this and Cij is given, which is a cofactor of A. Let B a matrix of order 3 where okay Aij is the entry is equal to cofactor.
Sir, I know the concept, but I am not getting the answer. Right, sir.
So this is just if you calculate the each cofactor and just substitute and then find B, will that be okay?
Yeah, that's what I did, but I'm getting totally wrong answer.
So this is just a numeric thing. Like you have to calculate cofactor. You can easily calculate and then find the value.
Has anyone else got the right answer?
No, even I got the wrong answer.
So maybe answer.
Sir, I am getting the right answer.
Actually, this is just a numeric difference. You are somewhere making mistake in the doing the calculation. One thing you can do, right? See, you have this one. You can take a screenshot of your take and post in Discourse and can ask that is somebody I am making mistake or like that. You can do easily because here is just if I will do what I will do here, just calculate. There is no concept involved here, so you can recheck your calculation.
Can you please explain what is cofactor?
So in starting I just discussed. You are there? Yes or no?
Okay, sir. I will watch it on.
You can easily watch. Otherwise, cofactor, okay, I can just now briefly tell, you can easily understand. What is cofactor? If you have a matrix, this one, suppose A11, A12, A13. Okay, let me make a bigger one. A11, A12, A13, A21, A22, A23. For 3 cross 3, I'm saying it will work for the 2 cross 2 also. A32 and A33. So suppose you want to find the cofactor with respect to this entry. Okay. So what you will do, just cross that corresponding row and column. Okay. So cofactor 2, 1. This is equal to minus 1 to the power, sorry, minus 1 to the power this ij. This is ij, this 2, 1 is I, 2 is I, and 1 is j. So ij is 2 plus 1. And now determinant of the remain entries A12, A13, A32, and A33. Now this is the cofactor of corresponding this. Similarly, if you want to calculate this one, just delete this row and column. The same thing. This is going to be Cj 2, 3. Okay, sorry, C 2, 3. This is the corresponding cofactor. Now minus 1 to the power 2 plus 3, as here 2, 3 is there, and determinant of remaining matrix, which is minor called, which is called the minor matrix called something is there. Getting no?
Yes, sir. Totally.
That's the process to calculating cofactor.
Okay, sir.
Okay, now I think Harsha is remain only.
Sir, I have a question. Practice assignment question 5.
Which practice? Okay, practice assignment. Question 5. Okay, this one. This one.
Yes, sir.
This is just a matrix multiplication. The purpose for giving this question is just a matrix multiplication. So which option you have doubt, or what is your doubt here?
I couldn't understand how to do this. Like, I found the weightage of like 89 into 20, 95. Sorry, 20% of 89, 20% of 95, and 60% of 80. I got something. I added all 3 of them, and I got something, but I couldn't find this any option matching my answer.
You get the second option.
Okay. Okay. So the question is, this persons are obtained marks in quiz 1. These persons. Okay, this person. Okay, these persons, and end same, quiz 1, quiz 2, and end same. Shown in table this one. And the weightage of final grade to calculate is this one. So final grade in 100. Which one is represent the which one will represent? Okay. So if you want to calculate, the first one is the first row represent the Sophia. The second row represent the Ram, right? And the third one will represent the Pratik. Pratiksa marks, right? So see, if you think it like this is 3 cross 3 matrix, and you are multiplying with the with this one, right?
Sir, you want to say that 2060 is the x, like ax equals to b. So you want to tell that 2060 is the x part. Is it?
No. I am saying this one, right? See, this is, we have like a 3 cross 3 matrix, this whole thing. Okay. And this represent the corresponding weightage of the whatever the weight is here. So what is happening? See, this is Sophia, this is something Ram, and this is Pratik, I think, whatever the name is. So what is the when you multiply with the weightage here written quiz 1, quiz 2, this is in same. So what is happening here? This row, these are the marks of right? Quiz 1, quiz 2, and same. These are the marks. Multiply this with this column. Will give the Sophia marks,
Okay,
right?
sir.
This one multiply with this one will give like this. This one multiply with this. This is the happening. This is the happening. Otherwise, manually you can calculate. What is 20% of it, 20% of it, 60% of it. Will give the first entry here, whatever the final grade of Sophia. Similarly, 20% of it, 20%, 60 of it will give the second marks, which is Ram having in the end. Like that, that's the manually. Otherwise, in matrix multiplication form, if you want to think, that is also happening here.
Okay, sir. Got it.
Okay. I don't know. I was just saying, I will start the concept. I clearing the doubts. Only the 18% is remain. I don't know it's this time to be discuss the concept or not. Okay. Anyone have doubt?
Not yet, sir.
Okay. Okay. So the thing is, there is not much participant. Many of have went. So from the next session, will taken by maybe Subhajit or Susmita. There from there, the concept will start now, because the problem with me was I spent 30 minutes to somewhere, and then otherwise the taking the sessions is the in this way, in the proper manner. First taught the concept, then we'll take the concept. Okay, so that will start from the next session, I think so, because now in this concept will be covered easily in these two sessions, and will let be done with the. Okay.
Okay, sir. Okay, sir.
Okay, thank you so much to all of you
Thank you,
joining.
sir.
Thank you.
And if you have doubt, you can stop me. I will clear your doubt. Otherwise, we will end the session. Okay, so no one have. Okay.
No, sir.
Okay, fine. So okay, thank you so much. Okay.
Thank you, sir.
Yeah, I hope I try to be clear your doubts as much as possible. Let's see that. Maybe in the next session I will be more ordered way, and maybe I will try to be more try to cover the more concept. This is the first session, that's why I took the random questions, random doubts, and I started to discuss. Now from the next session it will be in ordered way. Thank you so much. Good night.